So continuation of the threshing cylinder, the concave. In this video, let's see about the threshing cylinder. So the most important component of the thresher is nothing but the threshing cylinder only, because here is where the balanced rotating assembly comprising the ras beater bar or the spikes on its periphery and the support for threshing the crop is present. So there are many different types of threshing cylinder. One is a peg tooth type, wire loop type, ras bar, angle bar, and a hammer mill. So these are the pictures that differentiate the different types of the threshing cylinders. So you can see in the picture, we can see the peg tooth type, a loop type, an angle bar, ras bar, and the hammer mill type of the threshing cylinders used to thresh different types of agricultural commodities. So first, coming into the peg tooth, the teeth on the concave and the cylinder are arranged in such a way that the cylinder teeth passes midway between a staggered teeth on the concave. So the clearance between the cylinder and the concave is adjusted according to the requirement of the crops. So what happens is that as the stalks pass through the clearance space, the grains get separated from the head due to the impact action between the teeth. Wire loop is nothing but it's like the cylinder is being studded with an outer periphery like wire loops. So mostly wire loop is being practiced to thresh the paddy only. An angle bar is also a type of threshing cylinder where the cylinder is being equipped with angle iron bars that is helically fitted on the cylinder. What happens is that the bars will have a rubber pads on their faces. The clearance between the cylinder and the concave at the end is like 13 mm to 19 mm, and it reduces to 9 to 6 mm. So hammer mill types of threshing cylinder. These are the beaters in the shape of the hammer mill in only. So these are like a beater arm is being attached at the tip, and this what happens is that it will rigidly fix to a hub which is mounted on a main shaft. Rasp bar cylinder is nothing but it has a corrugated bars rounded where the threshing is accomplished between the corrugated cylinder bars and the stationary bars of the concave portion. So this rotating cylinder takes the grains out from the head as it is drawn over the bars on the concave unit. So usually when we can see a 6 to 8 bars are being spirally fixed on the concave. So this ras bar cylinder is also like this type of cylinders can be mostly recommended for the many different types of agriculture commodities. So next is the cleaning unit. So when we come into the threshing, so by using a few more technologies, they had fabricated this threshing unit along with the cleaning that is attached with the cleaning unit. So cleaning unit its role is to separate and clean the threshed grain. So it mainly consists of 2 or more oscillating sieves, a fan, and an air sucking duct known as an aspirator. So usually 2 ducts are present in a cleaning unit, that is a primary and a secondary duct. So what is the function of primary duct? It is, first it will remove the straw, dust, and the other foreign extraneous matters that are present. Secondary duct will finally clean the grain. So this is a thresher with aspirator. So this picture where we can see a blower shaft, a threshing drum, and a concave, an air duct, and a lower part of the screen where the threshed and the cleaned grain will be collected at the bottom. So after this we have to go in for checking the efficiency of the threshing. So how much of grains is being threshed? So how we can calculate is that the threshed grain that is received from all the outlets with respect to the total grain input, that is expressed by mass. So efficiency is equal to 100 minus the percentage of the unthreshed grain, we can obtain the efficiency of threshing. So what are all the factors affecting this threshing efficiency? First one is the peripheral speed of the cylinder concave clearance and type of the crop, moisture content of the crop, and the feed rate. So these are the various factors that affects. Then at last we have to calculate the cleaning efficiency also, that is M by F into 100. So M is nothing but how much quantity of the clean grains that we get from the sample that is taken from the main grain outlet. So F is nothing but the total how much quantity of sample that we have taken. So the total sample and the cleaned sample, by dividing both and into 100 we get the efficiency of how much grain is being cleaned. Thank you.